It's December 9th, 1868, Prussia, where a man who would change the world was born. He would grow to be a Nobel Prize-winning chemist, and his work would save the lives of billions while shaping modern society. But there was a darker side to his research, and some of the things he developed would lead to some of the worst atrocities of 20th century warfare. This man, of course, was Fritz Haber. Haber spent much of his early life in universities around Germany and Switzerland. In 1892, he would get an appointment to Ludwig Nohr as an independent assistant at the University of Jena. He would spend 2 years there, and then Nohr would help him get work at the University of Karlsruhe, where Haber would make major breakthroughs in the area of dye, textiles, and thermodynamics. During his time there, Haber would make perhaps one of the greatest contributions to chemistry of the 20th century. We still learn about this reaction and process today, and it is instrumental to modern society. Of course, I'm talking about the haber-bosch process. This is a process of nitrogen fixation from the atmosphere. You see, nitrogen is a very important element to life. But the most abundant source of nitrogen on Earth, which is the atmosphere, contains nitrogen in its diatomic form. The diatomic form of nitrogen is not very bioavailable, and to be used by life forms, nitrogen has to be in the form of nitrates or ammonia. Haber was the first to develop a process that we could take nitrogen from the atmosphere and artificially fix it into ammonia. Haber sought to solve this issue using Le Chatelier's principle, discovered in 1884, which states that when a system is in equilibrium and one of the factors affecting it has changed, the system will respond by minimizing the effect of the change. At the time, it was known that ammonia could be decomposed using a metal catalyst, so Haber did the reverse of this, using a high temperature and pressure to fix nitrogen from the atmosphere using a metal catalyst. He then went to Carl Bosch at BASF, who was able to reproduce this on an industrial scale. The Haber process is so important that an estimated 2/3 of the world's global food supply today is reliant on it. The nitrogen created by the Haber process is used to create fertilizer that completely runs our food supply. This makes it one of the greatest inventions of the 20th century. And our entire modern society is built upon its foundations. Unfortunately, our story doesn't end here. The nitrogen created in the Haber process is not only instrumental in making fertilizer, but is a main component of high explosives. And we were on the eve of the First World War. One of the main components of explosives at the time was sodium nitrate, also known as Chilean saltpeter. This was mined in natural deposits in Chile, but as World War I broke out, the Germans could no longer rely on that as an import, and so their entire explosives manufacturing process was reliant on the Haber process as they cut imports from South America. Haber greeted World War I with open arms, and as a staunch supporter of Germany and an established chemist, was quickly promoted into the chemistry department of the Ministry of War. Haber was instrumental in the production of gases such as chlorine gas and other toxic gases that were deployed in the trenches of World War I and became one of the worst atrocities that would happen during the Great War. Haber personally oversaw the first deployment of chlorine gas in 1915 at the Second Battle of Ypres. Chlorine gas is an extremely toxic gas and can cause severe irritation in even small doses. 160 tons were deployed at the war front, quickly overwhelming the soldiers in the trenches. When chlorine gas enters the lungs, it creates hypochlorous and hypochloric acid, which quickly melts away lung tissue and kills thousands within minutes. Those who survived suffered permanent issues in their lungs and even blindness. This single deployment of gas on the war front would result in 67,000 casualties. A few weeks later, After the Second Battle of Ypres, Haber's wife would take her own life. Merely days after that, Haber would be gone again to oversee the deployment of gas on the Eastern Front. Haber's researchers also created a cyanide gas called Zyklon A, which is used in agricultural purposes. This toxin is also a predecessor to the infamous Zyklon B, which was used during the Holocaust. Haber would never see this agent fully developed, as he would die from natural causes in 1933. Haber was not a good man. He showed little remorse for his wife or the thousands that were killed in the trenches. Haber is considered one of the most controversials in chemistry, and for good reason. He is the father of chemical warfare, and his work led to some of the worst atrocities of the 20th century and in 20th century warfare. We have to thank the Haber process for the food we eat every day, yet we also have to consider what it cost to get it.